In this video, we're going to talk about finding a tangent plane to a parametric surface. And we can define this by the following. The tangent plane at that point, u naught, v naught, on the surface, which is parametrized by the r vector, is the plane through p naught, which is normal to the vector r sub u cross r sub v, both of those evaluated at the point. So let's look at an example. Here, we're given the surface is a parabolic cylinder, and it's parametrized by r, a vector, in terms of x and y. We've got xi plus yj minus x squared k. X and y, the domain for both of those is all real numbers. So we're going to find the equation of the tangent plane at the point given, which is p naught, 1, 2, -1. So the first thing we need in considering our definitions up above is we need r sub x and as well r sub y. R sub x, so finding the partial with respect to x, we're going to end up with 1i plus 0j minus 2xk. And r sub y is going to be 0i plus 1j minus 0k. Well, by definition, we need the cross product of each of these evaluated at the point. Now we have two options. We can calculate the cross product and then evaluate at the point, or I can go ahead and evaluate r sub x and r sub y at these ordered pairs, and I don't have to deal with that at the end. Really, there's not much evaluating. There's only one x value to plug in. So r sub x at the point 1, 2, -1 is I minus 2k. And r sub y, there's nothing to evaluate there at 1, 2, -1, would still be just j. Right, but if we did have more multivariable functions here, we would just plug those values in for any x's, y's, or z's that we could find. So finding that cross product, r sub x cross r sub y, will be the determinant of this matrix ijk. I have 1, 0, -2, and 0, 1, 0, which gives us this. So we end up with 2i plus 1k. Therefore, we can write the equation of the tangent plane. We'll say 0 equals 2 times x minus 1, and that 1 comes from the given point, plus 0j. We don't really need to write that, but I'll just write that so it makes sense. So 0, and then we'll have y minus 2, and plus 1, we'll have z plus 1. Simplifying this, we're going to get 0 equals 2x minus 2 plus z plus 1, or rather 1 equals 2x plus z. So this is the equation of the plane, which is tangent to our surface, which is parametrized by r at that given point, 1 to -1. Now, you may be asked more with this question, especially if you're working it on the computer. The problem may show up as, or may ask you, to find the Cartesian equation for the surface, and then to sketch that surface and plane together. So what are the parametric components? We've got x equals x, y equals y, and z equals x squared. So here, x equals x, y equals y, z equals, I'm sorry, I said x squared up there, but it is negative x squared. And so that lets us know we can write this as z equals negative x squared. The x and y are only dependent on themselves, so z is dependent on negative x squared. And if we were to sketch this cylinder, it's a parabolic cylinder, along with the tangent plane at the point. So let me see, we got 1, 1, 2, because we're going to want to visualize that point. So what the cylinder, z equals negative x squared, it's a parabola, it's opening down, and it's traveling about or along that y-axis, since the y is absent there. So we've got some parabolic cylinder, which looks like this. And at that point in space, x equals 1, y equals 2, z equals negative 1, which if I draw a little cube in there helps me visualize. There's my point. And we have this tangent plane at that point, which if I look a little nicer, roughly like this. There's my tangent plane to the cylinder. So again, just a recap, we found the equation of the plane, which was tangent to the surface. We parametrized, or we took the parametrizations from R, and we developed what our surface might look like, this parabolic cylinder, z equals negative x squared. And then we sketched them both together. As always, email me if you have any comments, questions, or concerns. Good luck.